Hello, Math 7 students. This is Open Up Resources, Unit 3, Lesson 6. It's a 6th grade review of ratios and rates. Before we get started, we're going to do our quick poll warm-up. Students enter their answers into the calculator, and online learners are going to write this on your own paper to check for understanding. We need a ratio that is equivalent to 8/7, or 8:7. Here is the correct answer that was given to me in the calculator. How does an 8 change to a 16? CJ, we multiply by 2. So what's happening down here on the bottom? We're not surprised when it's also multiplying by 2. 7 times 2 is 14, 8 times 2 is 16. This is the correct answer, 16 to 14. Here's another correct answer. Jeez Louise. 1, 2. I'm not counting all the zeros. There's like a million more zeros at the end. How is an 8 changing to a 16,000? It's a tough one. Emma. We multiply it by 2,000. So we're not surprised when we're also multiplying by 2,000 on the bottom. 8 times 2,000 is 16,000. 7 times 2,000 is 14,000. Now, let's look at some incorrect answers. Knowing that I'm looking for equivalent ratios equivalent to 8:7. What is wrong with this? Have you found the mistake? What's the mistake, Gavin D? Exactly, 8 times 2 is really 16, not 18. I think that this student who typed this in probably just made a mistake. They probably just forgot that they can use their calculator and thought that 8 times 2 was 18, when 8 times 2 is really actually 16, right? Here's another one. Let's see if we can figure out what the mistake is. We'll do this one. Talk to each other. See if you can figure out what's wrong with this one. Because I had 2 students enter this. Okay, talk to me now. Come back to me. What is the mistake that was made, Savannah? Exactly. They treated this like a fraction, and that's why I've always been careful to say they're like fractions, right? And fractions you can turn into mixed numbers. However, this should be handled like a ratio, and ratios need to stay ratios. This question was not saying write something that is equivalent to the fraction 8/7. I needed an equivalent ratio, so I need to keep a ratio. And remember, this goes back to the definition of a ratio. A ratio is a comparison of 2 things, sometimes more things, like in our tuna fish casserole recipe from the other lesson. But this is specifically 2 things, 1, 2. So I should keep it 1, 2, and not have this weird third thing going on. Okay, so is the fraction 8/7 equal to the mixed number 1 1/7? Yes, but since we're dealing with ratios, I can't accept that answer because it's not a ratio. Here's one other answer that was not marked as correct, because I want you to understand that we are big kids now, and so we do write our ratios as fractions. So a student wrote something like this. Technically, is that a correct ratio? Yeah, however, the calculator doesn't count it as correct because it's written as a 6th grade ratio when we're big 7th graders, right? It is, and that's okay because all of these are the same ratio, right? They are supposed to be the same, they're supposed to be equivalent, but this needs to be written as a fraction. If this were written like this, the calculator would have recognized it as correct, and I would have called the name, but the calculator didn't recognize that because we're big kids, we're 7th graders, we write them like that now. Okay, hopefully we took some really good notes because I expect better tomorrow. I want 100% correct tomorrow. We've taken notes for 2 days now. We've done a lot of practice with equivalent ratios, so I want all correct tomorrow. Here's our new lesson. Again, this is a 6th grade review. This is Unit 3, Lesson 6. We're talking now about interpreting rates. Interpreting rates. So, I want you to think of something. Think of 2 different situations where you've heard of something per something. That means that you're going to replace this word here, something, with a thing that you've heard. And this word something is going to be replaced with something that you've heard about. So that we have per Does that make sense? Quiet think time. We're not talking right now. During this quiet think time, your pencils probably should be moving as you're thinking of something per something. Pencils should be moving as you're thinking about something per something. I'm looking for some students to share out. Something per something. What did you write down, Chandon? I think that would work. Little unusual, but that might work. That would be something like, I think you said 5 cats to 10 dogs, right?
Yeah, 5 cats
per 10 dogs. A little bit weird, and I'm going to tell you in a second how this one could be better, but you've got the right idea. It's something per something out. So this might be like at an animal shelter where there's 5 cats for every 10 dogs or something, right?
Somebody brought in 10 cats, they would all bring 10 dogs.
Yep, got it. Okay, Jackson, give me another one. Good. Cups of water. Cups of water per ounce. And since there's actually 8 ounces per cup of water, I actually like this one reversed a little bit better. 8 ounces per cup of water. Good. That's where I've heard that word per before. Give me another one, Gavin D. Say that again, 20 bricks for 40 cement? What does that mean, 40 cement? Okay, so 20 bricks per, like, slab of cement? I can't believe we haven't heard the most common one of all. Emma, you'll be the last one and then I'm going to move on. Puppies per dog. And that makes me so happy. We have a puppy who has been born and we're just waiting for him to be big enough to come home. And that mama had 10 puppies per her one dog. Yeah, puppies per dog. Guess what y'all forgot? Miles per hour. If you were 16 and driving, you would know that one real quick. Miles per hour. Oh. Okay, so have you heard of miles per hour? What does miles per hour refer to? Danny? Also known as? If someone's going 35 miles in 1 hour and someone else is going 20 miles in 1 hour, so you're referring to speed, right? Okay, so you guys got the ideas. Before I move on to the next page, or the bottom part of that page, which is cooking oatmeal, we're going to kind of switch this discussion a little bit because I feel like we need a little bit of a preview about how these rates work before we dive into the lesson. So I'm going to give you two situations, and I know that there's not a ton of space. You guys have a little bit of space up here, right, in your margin? And you guys have a little bit of space in here, and even a little bit of space here. So we're just going to kind of squeeze the notes in wherever we can. Here's the situation, okay? I have some family members that are going to be coming to my house for Thanksgiving. And one family member has to travel 150 miles. And it will take her about 2 hours. Okay, so that's person one. And the next person that I'm inviting over to Thanksgiving dinner, they live even further away. They live 225 miles away. And it's going to take them 3 hours to get to my house. What I want you to do is I want you to find the speed of each person. Speed. We talked about that just a minute ago, right? How do I find the speed of somebody? Luke? Yeah, we would do the miles over hours because this is miles per hour. So I'm going to do some color coding here. Miles per hour. Hands down, please. Hands down, please. Miles per, that means divide, hour. That's how I'm going to be setting up these problems. So, person one. Well, let's see. They're going 150 miles, so I'm going to put that on the top. 150 miles. Hands down. There shouldn't be any time for you to be having your hand up when your hand should be writing all of this down. Person one is 150 miles per 2 hours. And person two is 225 miles per 3 hours. But this is what's kind of interesting about these rates, right? And that's the change that I wanted to make here. I think this was this Chandon? Okay, that's the change that I want to make is normally when we have a rate like this, when it's something per something, it's usually per 1. We wouldn't normally say 5 cats per 10 dogs. We would just say 5 cats to 10 dogs. So when I use this word per, it's because that per would be a little bit better if I reverse this maybe and said 5 dogs per cat. Same information, only that's not right. Actually, it would be 2 dogs per cat, right? Yeah, 2 dogs per cat. But I'm using it per 1. So we've got these problems set up, but I want to try and make it so that it's not 150 miles in 2 hours. I want it to know how much per 1 hour. Work with your groups now. Answer these questions. Use your calculator. How fast are each of these people going to be going towards my house on Thanksgiving Day? Working with your groups to find these calculations. I want to know per 1 hour. Okay, let's now talk about this. You had your time to think and calculate. You had your time to discuss, to fix some maybe misunderstandings. What would we do for this situation? Hayden. Yes, 150 divided by 2 is equal to 75. So this person 1, is going 75 miles per 1 hour. Yes. Do you see how it says 75 miles and I say 1 hour, but you guys are just being lazy and saying 75 miles per hour? Because what does per mean? It means per 1. And that's why I wanted to change Chandon's first situation, because usually per means per 1. So we get lazy with our speech and we don't say per 1 hour, we just say per hour, because that means 1 hour. Okay? And what about the speed of the second person? 225 miles in 3 hours. How much is that in 1 hour? Hagen. Also 75 miles. 75 miles per 1 hour or 75 miles per hour. Okay, now I think we're ready for our oatmeal story. So let's go and take a look at oatmeal. And I already know that you all cook. Y'all told me that you cooked with the tuna casserole. So now making oatmeal is just another recipe that we're going to be looking at. Okay, here's the situation. Priya, Han, Lynn, and Diego are all on a camping trip with their families. The first morning, Priya and Han make oatmeal for the group. The instructions for a large batch say, bring 15 cups of water to a boil, and then add 6 cups of oats. Pretty easy recipe, right? Bring 15 cups of water to a boil, and then add 6 cups of oats. Priya says the ratio of cups of oats to the cups of water is 6 to 15. That's 0.4 cups of oats per cup of water. And Han says the ratio of cups of water to the cups of oats is 15 to 6. That's 2.5 cups of water per cup of oats. Question 1 asks, who's correct? Explain your reasoning, and it encourages you to use the table if you're stuck. We'll use the table together later. You can use it now if you want to. But you have these 2 different statements. Who's correct? Quiet think time for just a second. Read through those situations again. Who is correct, Priya or Han? Now, take your quiet think time into a group discussion. See if you can figure out who is correct, Priya or Han. Let's come back together, hands down. Who says that Priya is correct? Raise your hand. Who says that Han is correct? Raise your hand. Unanimous. Unanimously incorrect. Eyes on the screen. We're going to color code. I'm going to use blue and orange today. If you want to color code, you can also use blue and orange. Are you ready? The instructions say bring 15 cups of water to a boil and then add 6 cups of oats. Priya says the ratio of cups of oats to cups of water is 6 to 15. So, cups of water, I've done that blue. Cups of water, let's see, up here it says 15 cups of water. Here it says cups of water blue, and then it says blue 15. Is that all correct so far? Yeah. And it says 6 cups of oats, I did that orange. And it says cups of oats here in orange, and that would be 6. That seems correct, doesn't it? Uh-huh. And now, let's look at Han. The ratio of cups of water to cups of oats. Do you see how I'm keeping all of the oats orange and all of the water blue? Cups of water, 2 cups of oats is 15 to 6. So again, 15 cups of water, 15 blue, cups of water blue, Is that the same as the 15 cups of water that's blue up here? Yep, 6 cups of orange, both orange, or 6 cups of oats. Both of them are orange. Is that the same as the 6 cups of oats up here? So are these the same? Yeah. So who's correct? They're both correct. How is it possible that they're both correct when they're obviously very different? So how is it possible they're both correct? Now go back and rediscuss. How are they both correct? Okay. Come back to me and please tell me, how can they both be correct? What's happening here? Berkeley. Exactly. They're both using the same amount of ingredients, but they're just switching the numbers, right? They're just flip-flopping them. So they're both correct. So the question, and I guess the concern here, is this right here. We have different numbers, right? 0.4 cups of oats per cup of water, and that's 2.5 cups of water per cup of oats. Why are we having different numbers? Again, I'm going to finish the color coding here. Cups of oats per cup of water. So orange per blue, right? And then when I keep on reading, I see down here it's 2.5 cups of water per oats. Orange. Here it was orange per blue, now it's blue per orange. So if I'm going to flip them and swap them, right? Doesn't it make sense that the numbers here would also be different? Okay, let's look at this mathematically now. Hands down. Let's look at this mathematically because I want you guys to get in the habit of showing your work in a specific way. Okay? Even if you have a different thought process, I know what I'm going to be teaching in the coming days, and so I'm trying to set you up for success with these simpler problems on showing your work the right way. Okay? So you are going to be writing what I'm writing. You are going to be taking notes the way I'm taking notes. And we're going to start by setting up our problem. It says cups of oats, 2 cups of water, so that's 6 cups of oats. And I'm lazy, so I'm going to write oats instead of cups. So 6 oats. But you guys know that that means 6 cups of oats, right? And I'm not going to write cups of water, I'm just going to write water, 15 water. As we mentioned, that is cups of oats per cup of water. But what does this mean right here? Per cup of water. That means per 1 cup of water, doesn't it? That's a really big one. I see your hands, but I'm not going to be calling on them right now. Guys, I see your hands, but I cannot call on you because I am in the middle of a recording. Knowing that this is 6 cups of oats per cup of water, and per means 1 cup of water, that means I'm going to try and change this 15 to a 1. I want that to be just a 1 cup of water. How does a 15 change to be a 1? There should be more hands than this. You guys are in 7th grade. You've done this for several years. Danny. Sorry, Sam. Oh, I love it so much. He said multiplying by 1/15. Most students don't answer that way. What is the other way that you were going to say? Yes, I love, love, love that you're making that connection to our previous lessons and to our scale factor and everything else. So multiply by 1/15. And although that is 100% perfectly true, I'm running out of space, so I'm going to write the easier one that will fit in that space, and I'm going to write divided by 15. Because that's hopefully something that we remember from our old elementary days, that any number divided by itself is going to be 1, right? So 15 divided by 15 is going to be 1. So what should I be doing up here with this number? We should also be dividing it by 15. We have calculators. 6 divided by 15 is equal to We'll wait until we get those students entering it in their calculators. 6 divided by 15 is equal to Emma, 0.4. Exactly what it says it should be. 0.4 cups of oats per 1 cup of water. 6 divided by 15 is 0.4. And in-person students who are using the classroom set of calculators, you probably need to force it to a decimal to get there, right? Control Enter. Now let's set up this other problem in the same way. So again, we're setting it up with the information that's given. That is 15 cups of water per 6 cups of oats. But again, as we've seen in our previous problems, cups of water per cup of oats means per 1 cup of oats. We're lazy in our speech, so we don't say per 1 cup, we just say per cup. But now I know that the goal is to turn the 6 that's in the denominator into a 1. How does a 6 change to a 1? Good. Naim? I love it. Again, you guys are making such good connections. Yes, we can multiply it by 1/6. What's another easier way to enter into our calculators? We can multiply by 1/6, or we can, Miley? Yes, we can also divide it by 6. You got it. Good connection. 6 divided by 6 is equal to 1, so what should I be doing up here? Dividing by 6. We have calculators. 15 divided by 6. We're not surprised at all when we enter that into our calculator and we get 2.5 cups of water. So, who's correct? They're both correct. Let's make sure we explain that. Both are correct. I even like the language that you guys used in the beginning. They just swapped the ratios, right? They just reversed the ratios. They flip-flopped them, however you want to use that. You don't have to use fancy mathematical terms. They just flip-flopped. Or reversed the ratios. Okay, let's use a table. Show our work using a table. Yes, sir. It is a reciprocal. That is a fantastic connection to our previous lessons. And I'm glad that you use the fancy math vocabulary, but at this point, even just recognizing that reciprocal is flip-flopping or reversing it, that's fantastic. Great connection. Let's use our table to show our work in another way. Okay, you can see that the table's set up with the original ratio, water and oats, and we have water has the number 15, oats has the number 6. But I want you to notice this. In the water column, do you see how there's a row that has a 1? Because we want to ask that question, how does a 15 change to a 1? Notice how I'm showing my work. Same things that we did up here, just a new way of using the table to show that. And the 15 divided by 1, we're not surprised, 15 turns to a 1 by dividing by 15. So what am I doing here with this 6? Dividing by 15. We already know the answer. We've already calculated this. We're just filling in the table to show our work. 6 divided by 15 is 0.4 in the oats column. But we also see here in the oats column there's a 6. We just added a new number. But we also see the 1. And so that's the hint. How does a 6 change to a 1? By dividing by 6. So what should I be doing here with this 15? The same thing. Let's divide by 6. And 15 divided by 6, again, we've already done this calculation. 15 divided by 6 is 2.5. Easy peasy, yeah? Okay. That's it for today. We're going to finish this lesson in our next video. We'll see you next time.